Okay, looks like the recording has started, so let's get going here. So again, welcome to our monthly Ask an Expert session, this month featuring a discussion about simulating Intel FPGA designs using Questa from Siemens. My name is Steve. I'll give you a bit more details about logistics in a moment. But first, I want to introduce our expert for the month. We're very pleased to have a representative directly from Siemens, Karim Amizian. I hope I'm pronouncing your name correctly, Karim.
Yes,
is that
correct.
Oh, great. Yes. He leads the Questa simulation and debug product engineering team for Siemens, and he has over 24 years of experience in ASIC design and verification roles, as shown there. He worked with Synopsys before Siemens, leading the design, verification, application consultants, and customer-facing activities with other companies in the Valley. So he will present in a moment. Before we get to that, go over some logistics for how this session is going to work. If you have not, oh boy, I don't know what's going on with PowerPoint this morning here. It's skipping right past my slides. Okay, so that's very odd. I don't know what's going on. Anyway, so I'm Steve. I'm your moderator. You've probably heard me on a few previous sessions before. The whole point of this session is for questions. We love questions. So at any time, please feel free to ask any questions. You can unmute yourself and ask over the phone, or you can put something in the chat. I will be actively monitoring the chat, so I will forward questions to our experts at any point during the session. So please feel free to enter questions, follow-up questions, whatever questions you want at any time during the session. And I don't know why that keeps happening, which is very frustrating. Wow. Anyway, I'll fix it once Karim starts. So the ground rules. So any question you may have about Questa or model sim simulation with Intel FPGA devices is fair game. And again, you can ask over the phone or in the chat. If it is a detailed design specific question, we'll try to answer it if possible based on the description that you provided. If it's more detailed than that, something that we can't really solve in a few minutes in the session, then we will try to follow up with you, get your contact info, and direct you to your local FAE, who should be able to provide you with further assistance. So without further ado, Karim, you can start sharing and take it away.
Sounds good. Can you guys see my screen? I hope.
Yes.
All right, so let's get started. So yes, I'm Karim. I'm a verification product line engineer, I would say, for Siemens. So in charge of any verification simulation-based product. So Questa Sim being one of them. Today, we will look a little bit at the 23.1 release of Questa Sim. And hopefully with that, let me go to the next slide. Yeah, with that, I will also introduce to you the debugger that comes with Questa Sim 23.1, so our brand new debugger visualizer. We'll look at the new, I would say, optimization / debug flow to get the best simulation performance and debug capabilities, right? So how can you still get runtime and get your waveforms or get to debug accurately your design. We look also at this single step compile command named qrun that is very useful, especially when you don't want to spend too much time fine-tuning your script. At any point of time, I'm open for questions, so don't hesitate, don't be shy. I think that's, as Steven said, that's one of the main goals of this session, right? So, FYI, so Siemens has a whole verification platform, covering emulation, prototyping, simulation, definitely. There is design, obviously, technologies in the design verification technologies with formal verification, static. There is the analog, also simulation. And I'm sure you are aware that we cover many different markets. So today we will focus on the digital simulation one. One thing you need to know is that Siemens has been investing tremendously in simulation, investing and reinvesting. The past few years, we redesigned completely the optimization and debug engines, giving you capabilities also for parallel dumping, better gate level simulation, multi-core simulation with the parallel sim technology, new coverage engine, again, in order to get faster runtimes. Parallel simulation with SDF supported. So if you are in the ASIC world, be aware that we will also be supporting the SDF back annotation in multi-core. And we are coming with many technologies that I'm mentioning here, the Questa coverage accelerator, to look at those 5–10% of functional coverage remaining you're trying to hit, and it's quite painful to write those additional tests to get the 100%. So we have some kind of automated solution. Portable stimulus also. If you have a pre-existing UVM environment, we can take control of that UVM environment using a high-level description language to write those tests. So performance is a big focus for Questa Sim. Performance and debug, obviously, and yes, AI ML applications coming. I think that's true for pretty much any type of market today. In terms of engines, if you used the earlier versions of Questa Sim or use Model Sim, we've delivered over time different type of engines to give you debug capabilities with still some optimizations, give you full optimizations also, and faster runtime, but maybe not too much debug capabilities associated when the performance is required. So we are introducing the new engine called QIS, so Questa Information System. Basically, this engine is decoupling the optimizations and the debug capabilities in such a way that you will get the best runtime whether you run the simulation with dumping or not. So that's the main idea. This engine is also aimed to be used with our new graphical interface named Visualizer that I will show in the coming slide. So this new architecture, as I said, is enabling faster simulation performance, faster dumping also with smaller waveform files, right? So smaller footprint. And what we do basically here is that we dump what we call essential signals, input, outputs, flip-flop. Really, the essential, the signals. Those signals only once dumped will make your simulation waveform file smaller, right? And any intermediate signal is reconstructed on the fly, right? So any logic is reconstructed as we are opening your waveform in that area of the design. Those signals around the logic are used on the fly to reconstruct the intermediate signals. Sorry, and maybe this new damping technology here is also giving you the ability to dump your waveforms on a separate core, right? So it's multi-core dumping pretty much. So visualizer is basically the face of every verification tool available at Siemens. Whether you do formal static, you do linting, CDC, RDC, emulation, analog simulation, digital simulation, prototyping, you have the same look and feel. Okay, so a visualizer is what we call a context-aware simulator. So it will adapt basically to the context. It will adapt to the type of information you have dumped in the waveform, to the type of information you are bringing up in interactive. So you will get the right windows, the right option coming automatically depending on the context. Another thing also to be aware is that visualizer can be used, as I said already, in post-processing or interactive, for RTL gate level simulation. We have a UVM-aware set of features that will help you debug your UVM test benches, look at the UVM resources and configuration, the phases, the sequences used, whether you want to look at the source code, whether you want to look at the waveform, or also have some kind of graphical representation of the architecture of your test bench. And one I will go with the slide, and I will let you know more about it. Compared to the classic graphical interface, basically we are bringing a lot of new capabilities. You can see in this slide. Okay, so I will make the slide available. You can look at it in detail. But yeah, X tracing, I would say, is one of the most used capability here, as it's giving you, the root cause of the X, not only in a graphical fashion, when you do a back tracing and looking at the logic cone. We associate basically the physical information with the time or the trigger of that information, when that information was pretty much sampled, right? So if you do the X tracing, you will basically see where the X is coming from, right, in terms of driver, but you will see also when that X was driven. Okay, so that's the idea with this type of capability. So as I said, RTL, UVM. So I mean, whether you do design or test bench, you can look at your state machines. There is a lot of transaction level capabilities. So if you do UVM, if you do system C, transaction level test benches, right? So you will be able to visualize those transactions along your waveforms, and whether it's in interactive or post-processing. So I mentioned the X tracing. So this is what we call also the causality traceback, right? So that's what I was mentioning earlier. you will have this type of representation, physical representation, like a logic cone representation. And you see basically who is driving and that value, but you will also when it's happening, right? So you have these markers here in that window giving you the simulation time of the event, of when the event was triggered, right? So you have the time associated with that type of debug. I mentioned UVM. So UVM is an area of focus nowadays when you do design verification. So UVM is pretty much used in most of the test benches today, right? So you have, as I said, UVM schematic capabilities where you can view how your test bench is structured in a schematic fashion, right? In the schematic window, UVM is associated with object-oriented programming, right? So you have the notion of dynamic variable. Those variables can be then debugged pretty much, right? So you can put breakpoint in your source code. Wherever you put that breakpoint, you will see the value of those local variables. You can dump those local variables, put them in your waveform window if needed. So Visualizer is also a coverage-aware tool. So if you do code coverage, assertion coverage, functional coverage, you have access to basically this type of information in your database. So we use the UCDB database, which is based on the new coverage standard. So our database can gather all this type of information. Visualizer will be able to open and process the database and report the different type of coverage dumped in your tests. So obviously, Questa Sim has all the utilities to merge the different coverage DBs generated from those tests with those different metrics, right? So one metric we do support is also the test plan coverage. So you have the possibility to create a verification plan using one of our template and Excel. From that template, then you can open it in Visualizer and come associate any type of feature, any type of test you've been writing, and associate the corresponding coverage to that test or feature, and maybe associate a weight, to a specific cover point or specific cover bin. So I mentioned simulation performance. It's great to have a simulator that runs fast. Sometimes things don't run so fast. So you need to be able to identify what's slowing down the simulation, what's taking other resources of your machine, right? So if for some reason you are seeing that you're running out of memory after a few seconds of simulation. So maybe there is a bug in your design, in your test bench. So you have the possibility to debug that, right? So identify the constructs in your test bench or design that are responsible for that abnormal use of resources. Or maybe also you identify a construct that is probably not written in an optimal way. So there is ways, maybe alternative ways, I would say, that could be used to fulfill exactly the same capability and get less CPU and memory used, right? So, but if you have memory leaks in your test bench, for example, this type of tool here will give you will be able to root cause it for you, right? So the Questa SIM profiler is available through a set of switches that you enable at compile in memory, at compile time and runtime. So basically, once you've done that, we generate an FDB file. So with that FDB and a visualizer, we'll basically open it and give you this type of windows, right? So usually you get this first one here, and then as you select the type of window you want to look at, you will get one of those views. Okay, other screenshots here. So the switch to basically remember is -F profile. So -F profile can be used on the vopt command, on the vsim command, and on the visualizer command, right? So F profile plus perf will generate the FDB, the profile database. And then vsim-f profile, you have to specify it at optimization time, at simulation time, and at visualization time. So yeah, if you haven't played with the profiler, and if you have any question, you can always reach out to me. All right, so any questions so far? Been doing some talking. I haven't necessarily heard from you guys. Is there any question in the chat, Stephen?
We have not gotten any questions yet, though there was a request, which I have no idea if you're prepared for or not, to for you to do a demo. So I don't know if you'd be able to do that after your presentation or what, but if you can, I think people might appreciate that.
Yeah, I don't have a demo I can show, but I can share with you guys the links where you will find videos, right, of Questa SIM and Visualizer in particular, if that's something you're interested in. If there is any other type of capability you would like to see in a demo, let me know. We can set up a session if I'm not able to find the video. Okay. How about that?
Sounds good.
Okay. Yeah, the good thing with the video, you can replay them as much as you want, right? And post them and share them with your colleagues. All right, so let's continue with the QYS flow. Okay, so as I said, there's been multiple investment done, in the past few years. Many engines got re-architected really from the ground up. If you use basically Questa SIM or Model SIM prior to 2019, you were definitely using the plus ACC switches, the plus ACC switch, right, or a set of switches, because you have many different options available through the plus ACC, and you were using that to enable basically access to foreign applications like PLI, PLI-based application or DPI. UVM backdoors, signal spies, things like that. So whenever you needed also to dump waveforms, you were required to use the plus ACC options, right? So the challenge here is that the moment you use plus ACC, most of the optimizations get disabled. That means that you would run your simulation in a non-optimized design snapshot, right? that could result then in slower simulation. So yes, you can still do all the debug and use those foreign applications, with your simulator, but then you don't get the best simulation performance, right? Another thing also we saw is that the plus ACC options led to a lot of simulation behavior inconsistencies, right? Between a fully optimized run and a plus ACC based run, right? When I say fully optimized, basically it's whenever you don't use plus ACC, right? So lots of race conditions would be then exposed, good and bad, right? So it's good to know you have race conditions. You have to go debug them. It's probably not as good to find those when now the simulation is in the critical path, right? Because it's more things to debug. So you wish you would have debugged those before, right? So yeah, I'm not going to talk about race conditions too much today. So we do have options to do the race condition debugging. But anyway, just wanted to show you, one of the drawback of plus ACC. Okay, so and plus ACC still works, right? But in around 2019, we released a completely new architecture for access and debug capabilities that we named Questa Information System, right? And that is really decoupling debug and access capabilities, and then giving you also a finer selective access debug capability control, so that you enable only what you need. You enable only the type of debug or access capability that you need in a almost surgical way, right? So with that, also one thing we can guarantee now is that you'll get the maximum debug visibility with the minimum impact on your simulation runtime performance, okay? And you can combine that with capabilities like parallel dumping, and by default, all the waveforms we generate will be compressed and will be using basically on-the-fly signal reconstruction, okay? So you take all that combined, that gives you a super fast simulation, whether you need to debug or not, right? So, and one thing we've seen on many many benchmarks is that whether you enable the debug switch or not, the simulation performance is about the same, right? So, and if you do dump waveforms and use the parallel dumping interface, now the dumping is taken care of in a separate core. So the runtime is very, very close to the one when you don't even need to dump. Right, so minimum impact on the simulation performance. Okay, here's the animation 2x. So yeah, if you go from plus ACC to dash debug or dash access switches, you will most likely see around 2x simulation performance improvement. Okay, and say around, we've seen a lot more in many designs. Maybe on some we saw a little less than that, right? But that's we pretty much guarantee simulation speed up, right? And even if you I mean, and I would say, especially if you start dumping waveforms, right? Because now you get compressed waveform, and those waveforms being dumped on a separate core. Okay, so if you use plus ACC to just do post-processing debug and dump waveforms, right? So the change, you will have to go through would be to use dash debug plus design file. Plus design file will generate your qwave.db. Okay, that's the waveform. Okay, so if you say plus design file, no, sorry, I'm going too fast. Plus design file will generate the design.bin. that's the design database, right? So any Verilog VHDL C SysMC file compiled and optimized through that command will be shown in that design.bin that you can open with the visualizer command, visualizer design.bin, right? If you want the waveforms, you definitely need to enable the debug capabilities. And then at runtime on the vsim command, you need to say -qwavedb and enable, for example, signal dumping, right? When I say signal dumping, it's those essential signals, right? So port, you know, so input output registers, right? So you need the memories, or you need some VHDL records. You will need plus memory or plus VHDL variable, right? So that will generate the QFDB, okay? And that's the command to open the design database along the QWave database. So you can open the design database without a waveform. So if you don't have yet a test bench, you can still open the design database and do what we call design exploration. You want to look at your state machines, the architecture of the design. Want to look at, you know, if things are connected as they should be. You can do the design exploration with visualize or design.bin. You need to run the simulation in interactive mode. In live sim mode, same thing. Before you would use plus ACC, now you need to say debug live sim, okay? That will give you the ability to pass the -visualizer command on the vsim, right? Same thing for design file that creates the design.bin that you can open later on in post-processing.
Kareem?
Yes.
Hi, there isn't a question in the chat, but I have a question. What's the difference between a post-processing sim and a live sim?
So the difference is that here you run the simulation doesn't stop. I mean, the simulation runs, right? And when it stops, it generates the QFDB and the design.bin. Here with the -visualizer command, you have the visualizer command popping up, the visualizer GUI popping up, and simulation is not starting until you press the run button, or you have already a tickle command saying run. Okay, so here we run basically in batch mode. You don't have the GUI, and that runs. That command can run on your LSF grid, for example, right? Here you really want to control the simulation as it's running. You want to interrupt it. You want to bring some specific signals and look at them, debug in a live fashion, right? So that's what we call the.
So you see the results, like the waveforms fill in as the simulation is proceeding?
Absolutely, yeah.
Okay.
So the simulation is still going, and you can interact with the simulation at any point of time in a live fashion, right?
Okay.
So that's the only difference. So here
Okay.
there is no interaction with the simulation. It runs. When it runs, I mean, when it stops, you have your files and you open them and you look at you know, at what happened during the simulation.
Okay, great. Thanks.
Okay. You said there was any other question? No.
No, that was my question.
Okay. Good. Anytime. So yes. So let's continue. We do have, as I said, more targeted option, right? So you don't have to enable too many debug capabilities if you only need a specific one, right? Depending on what you're trying to do, you could just need the read access capability or the write access capability, right? So write access capability, for example, would be required if you have to write signals, right? You write on some of those signals using a PLI, a tickle command, a signal spy, a UVM backdoor, you know, or other infrastructure mechanism that require the write access, right? So if you just do UVM backdoor access, you know, to do read-write access, we do have a dedicated option, also. But you won't be able to access any other signal if it's not a UVM underscore command, right? So UVM read, UVM write, UVM deposit, etc. Right? So so that's done through this UVM access. If you need read capability and some write capability, you don't need to access the whole design. We can use allow write access. Allow write access will give you the write capabilities only on those essential signals I was mentioning, right? So intermediate ones, you won't have access to them because they are pretty much optimized, right? So so anything we optimize, you won't have access to it, right? So allow write access is this intermediate write access we give you to get you know, the best simulation runtime, you know, at least better than if you had to use access write capability. If you use also switches, you know, on the vlog or the, at least on the vlog command, switches like -y or -v, you know, those are typically switches you use when you want to compile libraries of cells, right? So if you have this concept of libraries of cells in your compilation flow, by default, we do not enable debug access on those cells. And that means that if you need to dump those cells and you still enable -debug, -access capabilities, we will not go dump them. If you need to dump your cells or libraries through -y-v, right, you will have to use this switch -cell access for the read capability, -cell access for the write capability. Okay, read gives you read visibility to those internal cells. Very common. It's very common in the gate level simulation, or it doesn't have to be gate level simulation again if you use -y or -v. Yes.
Kareem, we do have a question in the chat. I'm not sure if it's your area, so I might follow up with this myself. But someone's asking about simulation with our Neos soft core processor. I don't know if you've been involved with doing any simulations with any of our specific IP, including Neos, or if you have any insight into that. But I can follow up on this.
I haven't, but then this is probably considered as a foreign kind of application, right? Mm-hmm. And which means it's PLI or DPI or VPI, right? So then now the moment you want to debug also any kind of C, embedded C information, I would say, you would need to make sure the -G switch is used on this C commands, right? C compilation commands. But yeah, other than that, yeah, I don't know exactly what's the question.
Yeah, it's about our Neos IP. So I'm going to follow up and see if I can get an answer before the end of the session.
Okay, sounds good. So let me watch the time. Yeah, so let me continue. I think we're good in time. Other examples here of plus ACC versus -debug -access. You know, so if you have commands like that in your scripts, right? Plus ACC and PR. And you need to dump waveform, you need to force, or you need here to do some FSDB dumping, which is not the Q-wave dumping. It's another type of dumping. So you will need those corresponding switches, right? So it's pretty straightforward. If you struggle migrating from plus ACC to QYS, let me know. Okay, I'm happy to take a look at it. I do have also a link here in the presentation for our support that you can contact. Okay, so that's for the QYS flow. let me continue now with the QRun flow. So QRun is basically this single step command line. You can compile any type of information for the QRun command. You can give it VHDL files, Verilog files, C system, C, any options you need to run the simulation, bring up the waveforms, apply some specific optimization. You give it, just give it the switches you know and the files you have in hand, right? The tool will figure this out automatically. So even if you have text files in which you have basically file lists of Verilog and VHDL file combined, right? So the tool will figure it out automatically under the hood. It will generate the vlog, the vcom, the systemc commands, the C, C++ compiler commands to process all those files, right? So, so it's very intelligent and will find, the corresponding command and switches that need to be used. Automatically, it will trigger the VOPT stage, the optimization stage, to get the maximum optimizations applied to that simulation you're trying to run. And it will use the vsim command, extract the top that needs to be run. If you're not giving, I mean, you should still give it the what's the top design you want to run. If the VHDL files are not put in the right order, it will reorder them automatically. Okay, so same here on the QRun command. If you specify that you want to run in GUI mode, so you can use -GUI -visualizer. It will then run the simulation with your favorite graphical interface. Okay, so the QRun command is really a true single step compilation, optimization, elaboration, a simulation flow, right? So all the commands will be generated automatically for you. As I said, Verilog, system Verilog, VHDL, any type of simulator. I mean, any type of file, I would say, that should be supported by your simulator will be processed, right? So it's a make file style, I would say, incremental flow, right? So if there is only one Verilog command, one Verilog file or one VHDL file that is changing, it will not retrigger all the commands, all the vlog and vcom, and it's intelligent enough to see what's the corresponding command that should be run under the hood, right? So it's not going to recompile everything automatically. I mean, it's not going to recompile everything by default, right? So there is also the concept of parallel compilation, where if it has a lot of those vlog commands that are independent from each other, right? By default, they are. It will run them in parallel, right? So you can tell the tool to run them on your grid, for example, especially if you have lots and lots of compilation commands, right? So lots of files, and you want to reduce the overall turnaround time. Parallel compilation can be used, and it supports all flows, right? So whether you have power-aware flows with UPF, you have UVM, you have coverage, things like X-propagation or the low data flows are supported also, right? So you can do all that manually, all right, and try to compare it with QRun. QRun will make your life easier, I would say, right? So at least if you look at this type of command here, QRun -f, you can specify. I mean, you have lots of other options you can look at, right? And you can use. So here, for example, it's going to use this logical library UARTTB, and take all the files that are from this list, VHDL list file, right? So, and process them, do a basically a VCOM in this library, right? So VCOM in this one and this one, etc. Right? So there is we do have few switches you need to know, you need to be aware if you want to use the current. So auto order, and that's to be used when you're not sure about your VHDL ordering. If you want to know exactly what are the commands the tool is running under the hood, you can say -script output file. It will generate this output file with all the commands, and the current script will be running automatically. As I said, current supports visualizer. Use -GUI -visualizer. It will run automatically the vsim command with the -visualizer command. And by default, yeah, that's the other thing, is that by default, we will be dumping those essential signals I mentioned, but also any type of classes, right? So if you use visualizer, most likely you want to dump your waveform, you want to debug the waveform, and most likely any object-oriented kind of language that exists in your verification environment, right? So if it's Verilog, if it's system Verilog, UVM based, you will have that automatically, right? And that's it for QRun. Let me check the time. Okay, so few more things. Siemens has the Verification Academy group, right? So if you Google, anything around the RTL issues, you have a Verilog questions, a VHDL, a system Verilog, most likely it will redirect you. Google will give you a Verification Academy pointer, right? So and you once it takes you there, most likely it will take you in one of those forums where people ask questions, right? So it's open. You can log in for free. You can register for free and use that as a resource for everything around verification, right? So we do also, we do have a lot of free material, free tutorials on different aspects of the verification. I invite you to take a look. If you have any questions, you can go there and post your questions. We have people working 24/7 in helping the design verification engineers out there, right? So I'm sure you've all had to go in that verification forum, Verification Academy website at some point of time. If you need specific assistance on any Siemens tool, I recommend to go to support.sw.siemens.com. This is free. It's based on the SW, right? SW stands for software. So if you have any Siemens software, right, you have access to the support, right? So it's free to sign up. Same thing here. You will have access to a lot of information, related to Siemens tools. You have the documentations, the tutorials, and you have the support center also, right? So you can open a ticket and get the support center assistance, on that specific issue you're having with the Siemens tool, right? We do offer also a certain number of training resources available there. you do have access to a lot of videos, free videos, pretty much on any tool, right? So if you were looking for a specific capability of visualizer, you can go in on that website and pretty much look for that video, right? If you want to find all the visualizer video, you would just type visualizer video, and it will hopefully give you that information. If you're not able to find what you're looking for, shoot me an email. Okay, I'm happy to find the information for you.
Kareem, can I put your email address in the chat?
I'm gonna send the. Let me put it in the chat. Where is the chat?
Oh, I can do it while you keep
Yeah,
going.
you can put it in the chat. Yeah.
Okay, I just want to make sure it's okay.
Yeah, it's all good. No, it's okay. It's okay. You will. I mean, if I can answer, I will answer. Otherwise, you will get the answer from someone in my team, right? So I'm happy to get in touch with you guys. Okay. So as I said, as I presented, we've been investing tremendously, in simulation. So Questa Sim Visualizer. So our goal is really to get more users, more adopters, even though we are already the #1 simulator out there, right? So we are the simulator with the most number of users in the world, right? So you're looking for stability, you're looking for reliability. Questa Sim is the way to go. You're looking for performance, single core or multi-core, compilation performance and efficiency. So I showed the QRun flow. If you have questions on other technologies I haven't presented, I'm happy, to have a chat with you. We are, I think I said it already, or maybe I didn't, but we are the best support also, right? So we have the best support in the world for simulation, right? So don't hesitate. Again, if you need assistance, if you need help, if you need trainings, we can provide that for you. And that's all I had for today.
Great. Let me switch over here. Okay. So if there's any questions, this is last call for questions. I do have a question. So a couple years ago, we switched over the included simulation tool with Quartus. Previously, it was Model Sim, and now we include Questa Sim. If people have scripts or scripts that they've created back in Model Sim, can they easily bring them over to Questa? Is there anything they need to be aware of?
So if you want to go from Model Sim to Questa, it's pretty much instant, right? So assuming you're looking at using the same type of graphical interface and the debug capabilities, right? So plus LCC basically is still supported, right? We still have the classical user interface, right? So you can really go from Model Sim to Questa instantly, right? Well, the thing you would have to do now if you want to benefit of Visualizer is to convert any script where plus ACC is used, to a dash debug dash access flow, as I showed in the slide, right? So if you're struggling with that, reach out to me. Happy to get you the assistance and get that done.
All right. Well, I think that's going to do it for us. So thank you, Kareem. Thank you, everybody, for attending. I've put a feedback survey link in the chat. as well as a link, the link that Kareem gave earlier for Siemens support. But if you could fill out that survey link before you miss it, just to let us know what you thought about this Ask an Expert session, and if there's any topics that you might be interested in the future, please let us know. It's a very, very quick survey, less than a minute probably. But that's all we've got for today. Again, thank you, Kareem, for your time, and thank you everyone for attending. And we will finish up, and I'll be stopping the recording shortly. So again, thanks everyone.
Thank
See you
you.
next month. Thanks, Kareem.
Thank you. Bye-bye.